Okay, so guys, today what we're going to be looking at are congruent triangles. We already looked at on the first essential standard. When we looked at this essential standard, we looked at rigid transformations. So if we could do translations, reflections, and or rotations to get one triangle or one figure on top of the other figure, then that would show that these triangles or these figures are congruent. So we've already talked about the idea of congruent figures. In triangles, we looked at several different ways to make triangles. And when we're given certain information, we look to see, are your triangles always going to be congruent whenever you're given that piece of information? So that's what we're going to look a little bit today. Okay, the next triangle that we want to do, I want you to draw or construct triangle. Let's go LMN. And I want L to M to equal 2, I'm going to use centimeters, and M to N to equal 4 centimeters, and the measure of angle M to be 30 degrees. So on this one, since I don't have the lines on here, it's okay for you to use your ruler to measure and then use your protractor to draw your triangles. So I'm going to give you a few minutes and let you draw your triangles, and then we're going to compare those triangles. Okay, to construct this triangle or to draw this triangle, again, I'm going to need to actually use my ruler. We really don't use rulers on constructions, but we do want to draw this unique triangle. So I'm going to start with side LM to be 2 centimeters. So one endpoint would be here. The other endpoint, oops, I'm on a little bit too far, will be right here to be 2 centimeters long. So let me erase part of that line segment. Let's see, working too long. There we go. All right, so there's line segment LM. That is 2 centimeters, and it doesn't matter which endpoint you put as L and which one you put as N. It doesn't matter where you put your paper. You may have yours drawn somewhere else, but we know the measure of angle M is 30 degrees. So remember, when we measure with our protractor, we have to put the center of that compass right on the endpoint, and we line up the 0 degree mark with one of the sides, the ray that makes the angle. So if I'm going this direction, that 30 degree angle is going to be right here. It's going to go through this point. I'm just going to use a pencil for this. So there's my 30 degree angle. And then we know that the side MN is 4. So here is M. So N is going to be 4 centimeters out this direction. So I'm going to put this endpoint right at 4 centimeters. When I measure that, that other endpoint is going to be right here. So we know that N is going to have to go here. And then when we connect these two vertices, that's the unique triangle that we would make. So we know that this is 4 centimeters. So if I ask you to measure angle L, measure angle N, and measure the length of LN, we did that when we did the activity in class. And wherever your triangle is, wherever you chose to draw yours, when we're given this specific amount of information, maybe you drew yours in a different place, But this is your 30-degree angle. That's 2, that's 4. So maybe you got a triangle over here. It's still congruent because there's a transformation that could get us here. Maybe it's reflected somewhere. But wherever it is, we know that each of these specific values, each angle measure and each side length would wind up corresponding, being congruent because of the values that we have. So this is a side, and the angle in between, the included side. So this is called the side angle side. It's this, there's a side here, there's a side here, and we have that angle measure in between those sides. So if we're given that information, we know that that's the only triangle that I can make. It can be moved somewhere else on my paper in a different location, but it's going to match up to be exactly the same as anybody else that drew a triangle with this information. So side, angle, side.